Okay.
Thank you.
All right.
Okay. Thank you so much, everyone to attend this presentation. It's my pleasure to be with you. My name is Chris, and I work as an administrative assistant in charge of research and academic programs at the University of Global Health Equity, UGHE. It's in Rwanda. So being in the area of research brought to me the enthusiasm to keep working with R, hence keeping improving my skills about it. And later found myself, when you play with something for quite not even long time, you start discovering some things that are sometimes worthy to be shared with your community. That is how uh, this presentation of creating personalized dummy data sets, it came just with R. So the main aim here is to learn how, or maybe to share skills, or maybe any knowledge about how to generate some realistic dummy data sets using R. So this is like an essence of balancing data privacy with as well some authenticity. You can be testing, you can be developing, or maybe you want to maintain some confidentiality when you're doing any data science related or R related project. So feel free to stop me maybe when I'm talking, feel free to chime in when it's necessary so that the presentation becomes or is interactive. So uh, what do we need here to learn about? We want to learn about most of the important things like the definition, the application, and the advantages. Here, you might need the dummy data set in your life, and you can ask yourself, why do I really need dummy data sets? We have a lot of reasons. We have a lot of reasons, and those reasons lead us to creating some or mimicking the real data structures and distributions. Mine was, as the article says, if you have managed to read some article, my reason was actually to remain anonymous. Actually, I wanted to maintain user anonymity in the dataset for just demonstration. And sometimes you want to show your workers what have you done, and you want to show it, but without revealing the true information about the data you played with, or maybe the data you've discovered something with. In that case, you need to create dummy data sets so that you hide the true information, but you remain with the, like you, it's like copy pasting the quality and or maybe the properties of the data or the data sets or data structures without revealing the true scenario. So it can be used in software, in machine learning, in everything that is related to data, as long as you need populations. So I found this is important because I found it customizable, scalable, and it's free. And actually, it's even free. It does not conflict with legal constraints. So this is the most important thing I realized. So for me, I'm still like asking myself, the important thing is after understanding the why, now the definition, as I said in the previous data, the advantages also have been mentioned. This was to reiterate the importance of understanding them all over the presentation. Now, before that, allow me to talk about data privacy in this dummy data cell, data, in this dummy data. When I talk about privacy, I talk about protection, I talk about testing, and I talk about education. Because when you're protecting, you just want to protect the sensitive information, but maintaining the data, as you said. Also, when you're testing, you don't want to test with real data because it's risky. You just want to say, I want some data that I can use, especially when we are testing some algorithms and models in data science. We don't want to risk the real data. So this is really when it comes like to say this data needs to be as private as possible. And again, remember, we can say machine learning because machines learn. But human beings also, we need to educate ourselves because it's by observing data that when we can observe patterns, we can discover something we couldn't discover simply before observing those data. That's why educating yourself about those data, and remember, when you're educating yourself, you play with the data and you don't want to risk losing something. So you need to have a safe place where you can use in maybe teaching, uh, educating about some additional or new analytical skills or maybe analysis techniques, especially in this era where the education about data science is growing and new things are being discovered. So here, at any time, you might need to educate that thing to your community, and you will need to maintain data privacy. This is important. When we talk about all of this, they come as a result of scenarios. In a minute, I will be sharing with you my scenario, but again, I want to show you when you meet like some scenarios with testing dummy data sets, I keep iterating these 3 points: preparing your data, testing your data, and analyze them, because that's what keeps coming in when you meet any scenario when you're testing dummy data. It's like a cycle. It's like a cycle. It means you have to prepare your data. That's when now you're creating some realistic dummy data sets because they have the similar property. It's like cloning the realistic data sets, then putting there as the realistic dummy data sets, then test them to see that they release or they give you the information or maybe some yield or result you are expecting on realistic dummy data sets, but all of that happen without risking the sensitive information. And later you evaluate the results. Then that's where you can refine your models by retraining it, pre-training it. Maybe it's a supervised learning model and maybe something related. Just you want to see how those dummy data are those dummy data are performing to evaluate their performance. So there are a lot of benefits. You are learning in a safe zone, you are being realistic, but it creates a realistic practice. But again, you are complying with privacy. This like you're not exposing the sensitive information. For me, uh, I consider these as the three main benefits to train and educate yourself or your machine or any community about your data. Now, let's come to the realistic word when it comes, Chris. You may ask, Chris, what happened for you so that you dive into deep this thing? What really instigated all of this? On my working place, I was shared like an Excel file which had like 23 individuals. Remember, I told you I work in an academic setting and I deal with students' data frequently. And also, I learn from those data because I'm a data enthusiast. But one thing I want to let you know, I had three main components. I had the names, I had the sex, I mean male and female, and also I had citizenships. And the task, since they were from different nationalities, I had to make five main groups because there was an assessment activity and we needed to divide those 23 individuals into five groups, but we wanted to be as random as possible so that we are not biased, and we want to mix like not the same sexes to go together and not the same nationalities to go together. I mean citizenships. So it was a task really not easy, and I wanted to be as like objective as possible so that I will say this is what I based on to group you, and because in that case that's where you meet what I can call a data-driven decision. I had to make data-driven decision. So this is my case. And to show you as a name of, I mean, as an image of code, you can see, uh, I didn't want to mention the nationality as the dummy data set said before. You can see that the nationality number one, I had 13 individuals of them, and other nationalities up to, there were 8 nationalities. You can easily see that. And all of them, when you add up, they become, they add up to 23 individuals. And there is a note here. There is something odd that I met which further challenged me so that I can be realistic with myself, which even made me it encouraged me to go deep and create this dummy data set. It's because this group of individuals consisted of like 7 males and 16 females. Because at my university where I work, we have a policy of recruiting 30% males, 70% of females as a policy of my country and our university to enhance female education. So I had a table with original data, which had 4 columns, like the serial numbers, the name, the sex, and nationality, and I had to refer to that structure so that I can create my own dummy data set. So you see that I had to be as less biased as possible so that I can distribute these 7 males in each group to make sure no group has males and others do not have males, while others do are also not one nationality. You can see the first nationality is 13. I had to make sure that not all nationalities, actually each group had to have each of that nationality number one. So what did I do? How did I manage this scenario? That's where now I had to create some like empty data frame. It means I had to define its structure, where I dealt with columns and data types. I will show you throughout the steps I passed through. And also I had to use the data frame function. This one helped me to create an empty frame using R as that function. And also I had to set dimensions. Remember, in data science, in machine learning, in AI, we deal a lot with matrices. Those matrices are the tables. The tables will always require you to deal with rows and columns, which is like one of the major steps to follow. Then I started my first step at this stage. Please, if you have a PC, try to mimic my codes because I will be even showing the results. I try to make it as live or as realistic as possible. Even the minor errors which I had to make, I let them in the presentation so that it becomes more realistic so that you can even reiterate the steps. So my first step was to create that empty data frame with specified column. You can see that I created an object of dummy data sets. I called it dummy data. I initiated like a framework. Sorry, a frame. Then what I had to do, they're like placeholders of the population so that these ones will be the placeholders which will be populated in the future as long as I was moving. You can see integers. I created 23 because the sequence of numbers. You can see the comments. After each line of code, I tried to comment so that you can see how I did it and why I did it. So you can see everything there and how I created the placeholder for nationality, where the nationalities will be stored, the sex, the names, but the SN, which are the serial numbers, because we have 1, 2, 3, 4, I made them as integers. Then after that, I just had to explain, this is like in the talk, I just want to show when you're deciding about column types, you have to decide if it's numeric, if it's character, factor, or any other data types for each column. On the variables name, you have to choose the meaningful names. This is a best practice. When you are naming a data to sound professional, you don't just name it the way you want. You simply choose meaningful names so that they can even easily be referred to in the future. And then that's when you need to create some relationships. Why? Because some variables will relate to each other in your data set, no matter what. And you need to anticipate that, which leads you how to create all of this. Then this leads me to my second step, which is populating the SN and the names column. And how did I do it? You can see that the SN is the numbering by order and individual names. They were replaced by student one. It means here in the real data, we have the actual names of the student. But because I didn't want to reveal the name of the student, I said student one. Then the way like I passed through all of the list up to student 23 under the names column. You can see the first line of code, it says 1.23 as a sequence of 1 to 23. Then also the second line of code is creating the names of, because a student would follow each other like student 1, student 2 up to student 2023. And I want to talk a little bit about this. When you're using the data.frame function, you need to like take care of three main things. You need to take care about syntaxes. You need to take care about the column definition, because it has to be defined by each name with its name and initial empty values, so that those values can be stored later. And later, you will be also able to like specify the data types, and specify the appropriate data types for each column. So this one leads us to another important point I realized when you are creating the data frame dimensions. You will bear with me. I will be mixing my steps and some insights I got, which made me encourage me to prepare this presentation, because otherwise I'll just share with you steps and you are genius people, you can easily follow them, and it goes without presentation. But these things, I found them important so that I can share them with you, so that even within the discussion, you can even interact with me, and maybe I'm sure through the discussions I can learn something new, as we always learn from each other. So I wanted to emphasize about three main things. When you're setting a data frame dimension, you need to determine the size, you need to create the frame, and you need to verify. Because you want to, it's like building a house, and before equipping it, or maybe living in it, you have to see, like, you determine the size of the room according to the household size. You have to create the space. Let's say I have like two girls, one boy, or maybe one girl, three boys, so that each kid will have their room. And then before relocating to that house, you will verify. I think I can use that analogy to make it more understandable. So this will pave the way for you to understand why I had my third step, which is step 3. Step 3, it's assigning sex to names. Those names, remember, we have a different gender identities in our current world, but biologically we still have some, even if science keeps evolving, but currently we usually deal with male and female. So those names had to assign, even my realistic data set had male and female, not any other sex identified. So I had to set that seed for the reproducibility. So I had to choose randomly when I was assigning sex to the names, because student 1 and student 2, this time I had to make sure to have 7 males and 16 females for the whole data set to make 23. But I couldn't assign directly the real male to make it the male. I had to mix as long as I match with the total one. So this was not difficult. It's self-explanatory in the code, in the lines of code, and it can show the rep, the code, and the code is reproducible. You can like reiterate it. And without further ado, I started distributing the nationality, because when I had the provided distribution, as I described above, I ensured that the correct counts for each nationality. Remember, before I start our step 1, I showed you the representatives of the nationality. For nationality 1, remember it was 13. For nationality number 2, so that you can see the numbers in red, which is easily identifiable to add up to 23. Then that is when I needed to assign them as the nationality, as long as I maintain the distribution that is in the real data set. At this point, when you have done all of this, you need to see the outcome of what you're doing. You need to see, what am I doing? What is it yielding? That's when it leads to step 5 of viewing your first, like, you might have a long data set, but you want to view some few rows to see how it looks like. That's when you use this function of head and the name of your data set, which is head dummy data set. And I've screenshot the actual result within my PC so that you can also verify it of what happened. So this is the first observation. I saw this under my console pane. You remember in our environment we have four panels and one panel for console. That's when I saw, you can even see step 5, reviewing the data set. When I'm coding, I learned this I think it's in 2019. When I was in a training, I learned the best practice, like when you're coding, when you're like doing a project, it's better to narrate each step you're, and even to make it as self-explanatory as possible, because in the future, even yourself, you will need them. So that's the importance of commenting. You can see my screenshot, what I had for the first time. But for you, if you observe well, I had at the last column, even at the second, but I will focus on the second. I added mistakenly. That's how we do when we're playing with data. There is some SN, which is like a serial number. It's S.N, not S/N. This is mistakenly added, and the right one I want, it's on the last column. I had to fix this. This one created my sixth step, which was not really, which had not, if I had done this correctly, it would have like not appeared. But again, I did this to show you that you are allowed to try something. Remember, it's try and error, but also you to know how to get back to the right track. That's why I let this slide in so that you can see what happened when I was reaching to this step. But I needed to remove that. I circled in red, I mean this one, and also bring back the SN that is on the last column to the front one. This is my sixth step. I removed the unwanted SN, and this is how I removed it. I checked first of all, if the SN column exists in the dataset using that if condition, then if it exists, I said it should be removed and made it to now. And this led me to my like sixth step, where I want to show you how it happened, what it happened. It was removed, but my other column, I went step by step. It was still on the last like column. So I had to bring it on the first column. This is another step which was really not in the major step. It shouldn't happen, but as somebody who was learning, who was trying to play with code, who was discovering some new codes on how you can rectify and correct your data, I had to use some code which will be displayed on my seventh step. I commented by saying, I have to ensure that my SN column is the first column. It means I had to reorder the columns to ensure that it's the first column. This is the code to to order the column. It means the column order, you order the call names, then if not like the SN, and you like you put it on the first column. So this is what I did. And if you try this by yourself, I'm sure you will have a similar result to validate what I'm talking about. And this is now the final result, which I wanted. It's like I wanted them to be reordered. They were reordered, and that thing really is finally what I wanted. So this time, I made sure that Now, even if I can request to see all of the data, I will now see student 1, student 2, up to student 23, and making sure that at SN they are really well arranged. This thing really taught me how when you messed up with your data, instead of like panicking, instead of like getting like having like being frightened, you still have the purpose to again get back to the right track. So after that, what was remaining? Just exporting my data set. But before exporting my dataset, I want to talk a little bit about our variables so that we can have some common understanding, or maybe to give the room to sharing so that we can later understand some things together. So I want to talk about placeholders. When you are using the names, we need to use character vectors so that we can create the placeholders for first and last names. That is some details that firstly had escaped me, but later I realized it was necessary, but I embedded it later, but I said I will share this with people so that nobody will fall in the traps that I fell. I mean, in different errors. This is how we improve. We share our errors, what trapped us, and later we can now decide actually how to go. So for sex, I added the factor column to maintain the realistic distribution, and for nationality, we had a character vector so that we can reflect the diverse populations. So, and uh, I want to go a little bit in details about the names, but quickly, uh, it's like when you deal with first names, you need to generate a list of common first names for your data sets. The last name also, sometimes you need to separate the list of last name to use. I put this because somebody in the community might go and try, this time with no students. This is now with another data set which has no student. It means which is common, which has now differently set uh, population. That's when you will need first. Now, like if it's Chris, it can now finally become alias. Alias, it's a set of strings. It's a combination of string. It's a string, which like a set of characters coming together where it can be the first or second name. So I put this so that you can also brainstorm about it. And also you need to ensure the diverse range of names so that you can reflect the real world populations. Remember the main aim of dummy data set. It's simply to be anonymous, but still remain maintaining or reflecting the real world, the realistic data properties. And also adding the gender, sometimes like sex can be maybe sometimes interchangeably referred to, to gender. You need to use the R factor function to create the gender column so that you can create a factor. You can also maintain the realistic gender distribution in your data set, because sometimes you might have data where where population chose to say male, female, or prefer not to say to show. I forget. I'm sorry, you will bear with me. But there is a third option might happen. That's when you will need to maintain the realistic. So you will need to learn about the distribution, and also you will need inclusivity. So I had to put this because I just had data with male and female, but what if somebody else meets different gender? I mean, non-binary options. It means we need to be inclusive so that we can have the data set that can reflect the real world we're living in. Now it comes about nationality. You need to think about the diverse range so that you can represent, make sure there is a global representation. You need to choose some character vector because nationalities are not numbers, they are characters. And make sure now you distribute or realistically when you are like assigning different nationalities to such data. Look, those are the insights I realized. Then by adding numeric data, you need to identify variables you have, because sometimes you might need to have age, income, you need to set some ranges, and also now you can use different functions in R to create some random values That's where we need now the random. Remember, I had to use random when I was assigning the nationalities, the sex, the distributing. That's why I said it's important to talk about things of like generating data randomly. That's when will see a function like sample coming, so that the data, I mean, it will like this one will randomly select values from a predefined list, as we aforementioned in previous slides. Then you will deal with statistical distribution so that you can generate some realistic numeric data. Then to ensure consistency, you will maintain logical relationships. Remember, age and income has to be maintained. I mean, the logical relationship should be maintained. So this brings about a little bit details about the sample function, because you need to learn about their syntax, understand how the set is, the size is set, and how you can replace different options. And then you will know how to use them, because remember, we have different variables, especially for category code variables, you will need that function of sample. This is a little bit more technical, because we are talking a lot about functions, some technical terms, but again, it's something I couldn't afford to escape, as data scientists in-house can realize its importance. Then, when it comes to distributing, I talked about different distributions. So most of us, no matter what, when you're dealing with data, you have to learn about the distributions. So the major three distributions that I managed to realize, you can see the normal, the uniform, and the Poisson, the distribution. I just had to show what are the syntaxes, what are the functions. For normal, it's R norm. For uniform, it's R unif. For Poisson or Poisson, it's R poise. So this is very important. And also, when you're showing the data consistency, you need to identify the relationship, also to apply the rules and validate. Remember, when I say verification, I'm talking also about validating, because after verifying, you can validate and say, oh, I checked my data set, it has logical inconsistencies, and I correct them. And I even show an example of how you can correct your data as you are on the way to analyze them. That's when you will need to consider the data privacy. Remember, the major reason was to be anonymous. I removed all the the PII information. PII, personally identifiable information. I also made sure there are no real patterns. That's why if the first student was a female, I didn't say student one female. I assigned randomly. I didn't follow exactly how the patterns or individuals were, so that we simply hide their names. We just randomized everything, but we maintain the statistical relevant, which brings us to the balance. So as a takeaway, when you are considering the data privacy, think about anonymization, do it carefully, randomization, do it meticulously, and balance, do it with precautiously, I mean. So we have different techniques to anonymize, like data masking, generalization, and pseudonymization type. Pseudo means false. Pseudonymization. Bear with my pronunciation. But you can see how they are used. So this presentation is not about going into deep to these techniques, but at least revealing that they exist. It helps us as learners, as everyday learners. Remember, there is what we call yo-yo learning, which means you own your own learning. We can go and later after the presentation, we can even continue the discussion after the presentation to learn more. Same as in randomization in our dummy data sets. I won't talk a lot about how to randomize, but if I talk about shuffling, if I talk about noise addition, when you are like adding some small random variation, when you're talking about synthetic generation, you're simply talking about randomization in dummy data sets. And remember, after that, we talked about balancing. when you're balancing, you also have what you are using, you are referring to. You are referring to privacy and utility. Make sure I'm maintaining the privacy, but again, the utility. That's why you need to assess the needs, you apply the right techniques, and also you validate. Validating keeps coming. So after talking about this, let's come back to exporting our data. You have different formats within which you can export your data set. It can be CSV, it can be Excel, but again, it can be in R data, because remember, after you cannot finish one project in a day. You might need to come back. That's why I found saving in R. There is like one of the best practices is to learn how to save in R, so that you will know how to access some specific projects. This is what I did. I will also show it to you. Now let's start. When we want to export to CSV, just when use the function write CSV, then we specify the name, the path, and any additional points. Why do we do this? Why do we need to export into CSV? It's because we have different software and platforms that do not simply accept Excel files or any other type of files. But they can accept the CSV. So the CSV files they are becoming so crucial, especially when being used in data science. That's why I found it paramount to talk about how to export using the CSV. This was my eighth step, and it's time now to come back to the code. You can see this is like one line. Yeah, it's one line of save exporting, but it means a lot. I said 8.1 because 8.2 will be exporting it in Excel, but I wanted to let you know that I said dummy data because it was the name of my data frame, and the dummy dataset.csv is the name of the file I wanted to create. And again, when I set row.names to equal to false, I wanted to ensure that the row names, which are just row numbers in this case, are not included in the exported file. Remember, CSV, they are separated by comma. So I need to not include the row names. So please use that. You will see how a CSV file will come. For me, because I was dealing I wanted to have an Excel file to share it back with my colleague who does not understand about R. I didn't need to export it in CSV. I needed to export it in Excel. But I found it impossible, I mean, good to share both knowledge, because I knew that in the data science learning community, some people will need a lot the CSV files, which now led me to export it to Excel. Why? We needed a package, which is called write Excel package. It's in R. We needed the function of write XLSX to create an Excel file from my dataset. And also, we needed to have some formatting options, because remember, we're dealing with tables. We need those tables to be readable to non-data science people. I mean, like people outside the world of R. So that's why we needed some basic formatting options so that they can have a better readability. So it's a quite chunk of code, but which is understandable. Oh, and I wanted to mention here a small particularity about exporting data sets as an Excel file. You will need uh, some similar, like not similar, it's like a particular package. I can call it a package in your R session. It means like you will need the OpenXLS. How did I do it? You can see the code when I said, if I have to require that namespace, of course, it's true, then you leave it. But if it's not, now you install it. After installing that, you load it as a library. Remember, in R, most of us, when we are using some packages, we install them from the packages. Then after installing from the package store, I mean the R sessions, then we load them so that they can be usable. in our environment, IDE, I mean, like the environment in which you are coding. Then on the last line, it's all about exporting. Similar. It's like write Excel. I mean that you can see I explained it in the previous variables, but this is because it's Chris. Anybody else can name their variables the way they want. And after doing that, let me show you a screenshot of what I got so that you can see what I wanted. This is what I got. I screenshot. You can see now I made sure it's so small, but when you watch it, well, it's from 1 to 23. Student 1 up to 23. You can see in 6, they are like male, female, male, female. They are randomly assigned, but I made sure to maintain 6 male and, sorry, I'm sorry, 7 male and 16 females. And you can see nationality 1, nationality 1, nationality 1, nationality 4, somewhere nationality 8. No, like no particular pattern I had followed, but to make sure I distributed 8 uh, nationalities aside. I mean, to the table. It looked nice like this, and I created. I continued further to create them into groups basing on this one, so that if students could come, hey Chris, we also. I'm a student. I know sometimes we need to ask our leaders at schools, why did you do that? What did you base on? And the more you dive deep into data science, you need always to be as objective as possible so that you make informed decisions. I mean, data-driven decisions. You can like come closer and see how they came. And finally, I had this Excel. But remember, I told you, when you need to come back in your environment, you need to save your files in R. Let's talk a little bit about saving in R. You need to save them as R data. So you need to identify all the objects you want to save, then use the save function to create another data file, then load it later. And sometimes there is this best practice you need to save by adding the extension of R data. Sometimes we save it without adding that extension, but I think the advanced R environment are are giving that option, but before in the growth of during the growth of R, it was really crucial to add that extension. But according to different experience we all have in the house, we will share this together. So after saving that, what else? I need to talk about the best practices that I really saw will help you when you are doing all of this. There is realism because you will apply your the properties of your data set in the real world. So you need to make sure you close you as possible as close as possible you closely mimic the real data structures so that even when you are explaining, you will see that people will feel safe because they will know you're talking about something realistic. But again, you are maintaining confidentiality. This increases the credibility, the trust, even the project you're working on to say that they are reliable. But again, in everything you do, you have to prioritize data and avoid at any cost using any real personal information. In the introductory part of my article, as it was shared on Slack, I remember in the first paragraphs, I don't remember if it's 1 or 2 or 3, but I mentioned that even a small leak in data can make you sweat, can make you reach far because you have to make sure that's where the risk of that's where we have to prioritize data privacy in at any cost. And again, remember, people can guess, people have brain, not only people, even some robots can do that. So that's why you can make sure you incorporate enough variability so that you can test the different cases, different scenarios effectively. That's why it's like testing. And also I remember when I was doing some software development courses in past years when I was training in my career, I remember something called TDD. test-driven development. As you develop, as you work on your project, you test them. This helps you not making errors at the end of the project. But again, do you think I will go without talking about challenges and limitations? Because in every journey which is successful, it has to finally be what can I say? It has to have some complexity, some time investment, and sometimes the over-reliance. This is something we need to share as data scientists as we meet as many times as possible, because I don't want where I fail to let Simisani fall there, or maybe to let Tapera fall there, because maybe if she survives and continues, she will discover something more important that will also help me when I reach there. That's why I had to share the complexity, because trust me, if I be honest with you guys, I found it difficult to replicate complex relationships that are found in real data. This is something really you need to take care about, but again, it shouldn't hinder you, it shouldn't stop you to continue. Again, you need time. Remember, they say time is money, but to be honest, in the world we live today, time is more expensive, it's priceless. So you need to create some time, because this is time consuming, this is cumbersome, to be honest. But with your passion, you just invest your time in. I'm a cyclist, but if I tell you the honest, I'm not discouraging you from cycling, but 90% is pain. And because you are passionate about that, you invest that time by training yourself, because you want to improve. The same when you're like you want to create realistic dummy data. It's very time consuming. I don't promise like it's an easygoing task, but it's not a piece of cake you can eat in a while. But yeah, we continue, because as the more challenging it becomes, the better, because also we get we increase our confidence to deal with that. And again, you might overfit models to some dummy data characteristics that may also create over-reliance. This is something I found it as a limitations. Other than that, I have nothing else to say except thanking you so much for your kind attention, but mostly for exploring dummy data creation and making sure, I mean, hoping that this guide will make you like maybe reaching somewhere. But I want to remind you, not only practice makes perfect, but perfect practice makes perfect. Keep learning. I still keep learning until today. That's why even I'm here, and I'm still exploring R and any other data science techniques. And why not? I'm daring to innovate, because I don't need to be a guru in data science to innovate. At least I use the little I've known so far to see if I can create something new. That's where now we try new ideas and algorithms. And the most important thing that will make us really successful in our career is being ethical, staying ethical. What do I mean in data science? Is to always prioritize data privacy and be having a responsible use. That will affect your reputation. And one like mentors told me that you have to prioritize always your reputation, because it's the only thing that stays living after we die. So by staying ethical, I will prioritize my data privacy and responsible use, but again, increasing my credibility and reliability, which will improve or maybe affect positively my reputation, hence living a second life even after I'm gone. Thank you so much for your kind attention. Over to you, Simi.
That was really good. Thank you so much for that, Chris.
Welcome,
Hello,
Simi.
Chris.
Thank you so much, Tinashe.
Great job, Chris. Yeah, I wanted to reiterate just, how thorough and well presented this is. Um, you've done the due diligence to just make sure that you hit on all of the important details. Um, I wanted to ask how you would approach this problem, um, say if you were dealing with data that isn't normally shared via something like Excel or CSV, like if you had data that was part of, maybe some kind of study or, maybe medical data in a hospital or something like that. Um, would you probably implement the same kind of strategy?
Yes, please. And I'm happy that you asked these questions because I work in a medical university. If you search well, the University of Global Health Equity is a university which has a bachelor's in medicine, and I do a lot of research when it comes to clinical trials and different settings when it comes to medicine. But guess what? This is possible because sometimes you will have a patient. One of the most sensitive data is patient data. You might have different research that are being like conducted on, let's say, patients with diabetes mellitus or any other disease or maybe any other health condition, and you might need to keep doing some some analytical things, and you need to maintain an analytical integrity. That's when you will need to hide the personal identifiable information of the patients. But again, you will need sometimes even to hide their condition. Let's say you are dealing with HIV results of the patient you have. Maybe you need to show from a data set the gender of the patients, but without revealing their status. That's when you will need now to see to see how you can deal with the column that shows the status of your patients. So in medical, thank you for asking even the right. Actually, for me so far, with the experience I have till today, uh, in medical settings, that's where this privacy is really needed so that you can even allow third parties to access those data because sometimes the ministry or maybe any other important body might need those data, but without needing to know exactly the names or the reality of the data about patients. So for me, so far, I found them possible, and I'll be happy if you want we keep cooperating and maybe one day we work together on a project and we can see how we can customize this concept and principle on your data if you have some.
Yeah, no, definitely. I'm in a PhD program in the US, and we work
Mm,
with study participants, particularly students with stress, and so
mm,
protecting their information is obviously very important. Um, One other thing I wanted to just mention,
mhm,
it's kind of related to your work. Um, I've sent a note in the in the chat. Um,
mhm,
where you can actually generate fake data sets for your tutorials and things like that. But
mhm,
it looks like this package, it's called Fakeair. It's not
mhm.
it's not based on existing data. It's based on just um, hypothetical data. But maybe at some point we could look at the algorithms that Fakeair uses and see if they can be implemented in your workflow as well.
Oh, thank you so much. I can see even you sent me the link to your repo, your GitHub repo. I'll be happy
Yeah,
to visit
this is
it.
that's the GitHub repo. Yeah.
Yeah, and I'm afraid this link will disappear after the meeting. Can I share my email so that you can send it
Oh,
to it?
it will be preserved because the chat from this Zoom meeting will go into the chat on Slack.
Oh,
It'll
that's
automatically be
great.
updated
Oh, yeah, that's great. I'm happy for that.
as long as Ndaba has pressed start and stop.
Yeah, that's great. Listen, Ndaba is taking care of that, and I owe her a big thank you. Yeah, thank you
Yeah,
so
no,
much, Tinasha. I'll visit it, and I'm sure we will learn from each other. And I know how PhD is really not easy. So all the best I wish, and really congratulations because that it requires somebody brave to take over PhD. PhD is not easy.
Yes, thank you.
And I can't wait. You are in the third year, right? I mean, the last year, or you're amidst.
I'm in the mid-year, third year
Oh, yeah,
of maybe
don't
five.
worry. Yeah, the journey you are remaining with is shorter than the one you have already so far covered. We can't wait to celebrate you. Thank you.
Hi, Chris. Yeah, I've also got a, well, not a question, but I first have a comment, suggestion, and then a question. If you go back to the slide that talks about the limitations and the
Simi,
challenges.
Simi, your voice is breaking. I'm not getting you.
Hi, how about now?
Yeah, now I can hear you well.
Oh, I think it was the volume was low. I think I have a suggestion, comment, and then a question. If you can go back to the challenges and limitations page, one of the limitations and challenges was changing it to personalizing the dummy data. Yes, is the second part was time investment. I was thinking that maybe like over time, if you keep working on it, you could maybe create a pipeline from it. Because looking at the top, it looks as though these are best practices or steps in creating dummy data. So in creating dummy data, you can turn it into pipelines that they can follow some processes and can even be automated eventually
Mm.
or changed
Yeah.
somehow like that. And I think Tanache actually answered my question. I was actually going to ask where you can use dummy data, how you can personalize the dummy data set, and that's when you talk about medical records and patient files and things like that. I wanted to add on how the dummy data could be automated eventually.
Oops, I hope I'm missing some part of your question, Daba. The last part.
No, the last but Tinashe actually answered my last part about how it can be used, the way you can apply it, and that's when you mentioned that it could be used for patient records or other personalized data, like people in gambling or doing a survey, or people who are in HIV treatment and things like that.
Okay. Well, according to, I don't know if Tinashe has managed to hear you all of, but what I can add on what I had said before when I was answering Tinashe is also there, I forgot to mention about electronic health records, the EHR, especially when it comes to health informatics. Sometimes there are some, maybe you can have a different presentation about this, but in EHR management, when you are like in health informatics practically, there are ways, different ways actually to manage databases so that we can uh, still apply this to patients. And not only in patients, but also some different studies might be carried out on refugees, refugee camps. Remember, when it comes to refugees, you need specifically to, refugees, like they are the amongst um, the most vulnerable population when it comes to health issues, and that will incur a lot of informations, like the existence of a lot of informations, especially their records, because most of the time their vitals are recorded. We need to follow them up each and every day. So by complementing this with the access and understanding of the use of handling data with EHR, I mean like the electronic. I don't know if I hit the right answer according to what I understood.
No, 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 you definitely did. I think actually you it was an add-on to the question.
Oh yeah, yeah. Thank you so
And
much,
where else?
Simi.
When where else? I think I'm done with questions. Everything is clear. I don't know about Tanasha on his side. If there are any more questions that he has.
Any more questions, suggestion, additional thing, Tenashe?
Yeah, I think he says he's good. I'm just gonna end it in the chat. Is this where you want to end, Chris?
Yes, please.
Oh,
And
all
thank
right.
you so much for your participation and attendance. I'm really glad you just showed up.
Oh, thank you for your talk.